Section 1.2 is integers. We talked briefly about integers last time, and we defined them something like this. We didn't actually write down a definition, but we talked about it. Integers are whole numbers with a signed value. So it's either positives or negatives. And when kids are first learning about different kinds of numbers, it's often sort of this intuitive thing to say, well, that doesn't make any sense. That's not real. I mean, that's just sort of this made-up mathy thing, right? And it actually happens all the time in real life, negative integers in particular. So I wanted to give you a couple of examples of integers in real life. So it can be 50 degrees Fahrenheit or negative 50 degrees Fahrenheit outside. Now, for those of us who are from the South, you're like, negative 50 degrees? I don't believe it. So we lived in Ohio for 3 years, and my husband was a part of a ministry at our church that was, he had to pick up food. And the mornings when he had to pick up food in the dead of winter and in the storage container where he got it, it was negative 40 to negative 50 degrees often in the wintertime. So, I mean, they were dressed with gloves and these boots, and like it was insane because it's really hard to keep warm in negative 50 degrees. So, negative temperatures. I suspect we've all seen negative temperatures, maybe not negative 50 before, but negative temperatures happen before. Another example is that you can be 1,000 feet above sea level, or negative 1,000 feet above sea level. Contextually, we probably would call that like thinking about it as being 1,000 feet below sea level instead. Okay, so maybe you actually are scuba diving, so you're below sea level. That's a possibility in the ocean. But also, there are places on land that are below sea level in terms of the altitude and their nearness, if you will, to the core of the Earth. So that's another context. One of the ones that you may personally have experienced, I'm not going to write it down, is having negative dollars in your bank account. I hope not. It happened to me when I was your age once. I remember, very disconcerting. It turns red, and people get mad, and they start charging you fees, right? It means you spent more than you actually had in there. It's a negative amount. And to be honest, anytime you have a credit card statement, it's a negative amount too, because it's money that you owe because you haven't already paid it for whatever purchase you've made. So we see negative numbers everywhere, actually. From a number line perspective, we talked about this briefly but didn't do any examples last time. If we have 0 on our number line, we worked with positive values last time, and we talked about the fact that we moved to the right. So we'll do 5 over here. So from 0 to the 5, and it's 0 to 5. And if we need negative 5, we would go to the left. Now, anytime we do a number line, if you feel more comfortable with writing in some of the digits instead of just leaving hash marks like I did, that's fine. Try not to write in so much that you can't read it anymore because you're trying to, fill in too many details. But yeah, these would be the numbers. Let me put the dots on the line, sorry. 5 and negative 5. So smaller values to the left still, right? Negative 5 is smaller than 0, so it's to the left of 0. And 5 is bigger than 0, so it's to the right of 0. So I have an example here for you that I would like for you to plot, 10 and negative 7. So just put a 0 on there and then go from there. So where, roughly speaking, did you put the 10? To the right of the 0, right? So you should have had 1, 2, 3, 4, 5. Maybe you want to hash mark by 5s. Something like that. So you need to label that it's 10. I don't want to have to count the hash marks, and neither does the grader. And you need to put a dot on there representing that you've actually placed a point there, okay? So then that means the negative 7 would have been to the left. Again, if you want to reference maybe the 5s or maybe every other one, depending on what's going on, you can do that. You don't have to put those in there, but if you want to, you can. And then there's my negative 7. To the left, to the right. All right, so some basic ideas about integers. I suspect most of these are things that you will remember, but just as a way of clarification. While 9 is less than 10, negative 9 is actually greater than negative 10. And one way to think about it is sort of where it's occurring on the number line, right? Negative 9 is further to the right on the number line than negative 10 is. So if I were working over here on my diagram and I had negative 9, it would be here, right? This is negative 9. And if I had negative 10, it would be here. So negative 10 is actually smaller than negative 9, or you can say that negative 9 is actually bigger than negative 10. So if you think about it in terms of a number line, it's perhaps easier to keep it straight sometimes than if you think of it in terms of positives and negatives and distances and things like that. Where would it be on the number line? Which one's further to the left? So I'd like for you to take a second and do your best to fill in the blanks on those two examples. Remember, there's going to be two answers that you could use. So while you may be able to use the less than, you could also use the less than or equal to. Those would both be equivalent answers in the blank. On your homework, it just tells you usually which type of values that it's using. Does it want you to use the less than or the greater thans, or is it asking you to do the ones with the equal signs? So fill in the two blanks. And then once you have, somebody tell me which one you put in the first blank, negative 3 and negative 10. It is a greater than symbol. Or you could put the greater than or equal to, right? So one of the sort of visual ways you can keep track of that too, sometimes people get confused with the symbols and the directions, especially if symbols are kind of not your thing, is that the mouth, if you will, of the symbol is opening toward the bigger number. So negative 3 is larger. It's further to the right on the number line. So the mouth, you guys know what that guy is? He's Pac-Man. He's going to eat the bigger value, right? So the mouth of our symbol will open towards the larger value. So how about on the second one? What symbol goes there? It's also a greater than, right? Or you can do the greater than or equal to. Be real careful that you don't get too carried away looking at the 2 and the negative. I mean, the 2 and the 5, right? The signs matter. 2 is further to the right because it's actually after the number 0 on the number line, and negative 5 comes before the number 0. So the values 5 and 2 don't matter so much on this one as the fact that one of them is negative and one of them is positive. All right, any questions on number line stuff? Because we're going to shift gears. It's all good? Awesome. Okay, so we're going to take a look now at some addition and subtraction ideas. There's 3 different things that we need to sort of be aware of when it comes to addition and subtraction and how we deal with them a little bit differently. So one option is that you have the same signs. So the same signs means they're both positive or they're both negative. So if that's the case, what you do is you add the values, whatever those values are, ignoring the sign, and you keep the sign. So if they're both negative, the answer is negative. If they're both positive, the answer is positive. So that's what happens when we have the same sign. If our signs are different, right, one's positive and one's negative, it means you subtract larger value, again, ignoring the signs, you subtract larger value minus the smaller one. and use the sign of the larger value. So let me just put that in here because I think that one sounds a little funny when I write it out in words. But if we had 5 minus 7, we aren't really going to write down 5 minus 7. In our mind, we're going to think 7 minus 5. And what is 7 minus 5? 2. And then because 7 is the larger value and it's negative, then it means that the answer to 5 minus 7 is the 2 that we just got, but it's the negative because the 7 was a negative value and it was larger. Okay? So you kind of ignore the two signs for subtraction purposes and you subtract larger minus smaller, and then you just keep the sign of the larger value. All right, the last thing is what happens when we subtract a negative. So anytime we subtract a negative, what that means is that we actually have something that looks like this, right? Minus a negative. One of my sons likes to say minusing. It's not a real good word. I keep trying to tell him it's subtracting. It's minus a negative, or it's subtraction of a negative. That actually means you have a positive value. So again, if you had 7 minus negative 5, that would actually give you 7 plus 5. So double negatives actually equal positives. And we'll come back to that idea in a little bit when we get to multiplication as well. Okay, so you've got 4. There's 4 examples. What I'd like for you to do is this. I'd like for you to get your best answer, what you think based on what we've talked about and the prior experience that you have to those 4 examples. And then I'd just like for you to turn to somebody near you and just compare. Did you get the same answers? And if you didn't, see if you can figure out where the error lies on whose paper so that it can be fixed. And then we'll come back together and we'll make sure that everybody has the same thing. So it should just take you a couple minutes. Okay, so just, you don't need to swap, but just share your answers with somebody near you. Just make sure they match real quick. Sure. Do you want to sit there permanently? Do you want to sit there permanently? Okay. Elijah, right? All right, so what did you guys get on the first one? Negative 13. So the signs are the same, right? So we add the 6 and the 7, that gives us the 13, but the signs are negative, so we would keep the sign of the negative, right? So we get negative 13. How about the second one? 1, yeah, and it's positive, yeah? Right? So we have different signs on this one. The 7 is the bigger number, so 7 minus 6 would give me a 1. And the 7 being the bigger number is a positive here, so it's a positive 1. How about number 3? Negative 2. Different signs again. So 15 minus 13 is 2. But the sign on the 15 this time is negative, so we end up with a -2. And the last one is an example of the third one where we have the signs that match, right beside each other. So minus a -2 is the same as +2, so you ended up getting the answer of 8. Okay, any clarification needed for any of those? Okay. All right, so we're going to move on then to multiplication and division. So one of the key ideas with multiplication and division is that we will multiply the same way we would if we had positive numbers to begin with. So none of that changes. So all your multiplication facts that you learned back in 3rd, 4th grade or whatever, none of that changes when you introduce negatives. The only thing that you have to be careful about is the sign, right? So when you have a positive times a positive, what does that equal? A positive, right? That's like before you even knew negatives existed. You already had that idea. So what happens when you have two signs that are different, right? A positive times a negative. That's when you get a negative. And that last one is kind of like what we experienced over here where we had the subtraction of a negative. It's two negatives right beside each other with multiplication this time. And it's also a positive, right? So a negative times a negative is a positive. Has anybody ever seen the movie Seen and Deliver? It's a really old movie. Highly recommend it. It's super 80s. Like if you watch it, you're going to be like, yep, that's 80s. It's about a high school math teacher in California, and he talks about a negative times a negative equals a positive. And what it is actually his story of Jaime Escalante and taking kids from a very low level of mathematics all the way through calculus within about 3 years in a high school setting. It's a pretty remarkable story. Anyway, so we're going to do some examples where we have negatives and positives with multiplication. I want you to do the same thing you did just a minute ago. You've got 6 questions. Do your best on the 6 questions based on the information that you've learned before and we've reviewed today. And then collaborate with somebody nearby and see how that goes. All right, you guys ready to check? Hear a lot of good conversation going on. That's good stuff. So on the first one, just tell me what the sign is first. It's negative. And what's 6 times 3? 18. Awesome. What's the sign in the second one? Positive. And it's positive what? 32. How about the sign on the third one? Negative. And so I didn't actually sort of identify over here. This says multiply and divide as normal. And I told you on step 2, like this times this. It's true for multiplication and division. So I could have equivalently written like this. Okay? So if that was not clear, I do apologize. Division works exactly like multiplication on signs. So it's seamless. So that's beautiful on number 3. A negative and a positive are still a negative. And so negative what? 8. Good. How about my sign on the fourth one? Positive. Positive what? 4. All right, 5 and 6 are a little different because I have more than just 2 numbers. But if you take a look, I only have how many negatives? It's 1 negative. So it's just like having a negative and a positive over here. So this one will end up being what sign? Negative. And negative what? 36. On number 6, if you actually are sort of being careful, you'll notice that I have sort of pairs of negatives, right? So the first 2 actually being negative means I'm going to get a positive. And the second 2 being negative means I'm going to get a positive. So my sign ends up being positive overall for all of them. Positive what? I have 120 written down. Let's double check it. So what's 3 times 2? 6. So I have a 6 at the beginning. And then 4 times 5? 20. And this isn't the only way you can do it, but you could. Then I have 6 times 20. Right? You could move from left to right. It would work the same way. This grouping is kind of nice because I'd already written down my signs for it. And then 6 times 20 is 120. Okay. Does that make sense? You good with that? Yeah? Awesome. All right, we have one more idea to encounter here before section 1.2 will be completed, and that's the idea of distance. The distance between 2 values is actually the larger value Actually, let me just say larger number. I like that better for what I'm talking about here. The larger number minus the smaller number. And by larger and by smaller, I mean the one that's further to the right on the number line. Right? Further to the right on the number line, that's your larger value. So if you wanted the distance between 2 and 6, the larger of those two numbers is 6. So it's 6 minus 2. If you wanted the distance from 2 to negative 6, which one of those two numbers is larger? The 2 on that one, yeah. So you'd have 2 minus the negative 6. What's 2 minus negative 6? Close. It's 8. So we have that double negative, so it changes the signs, right? 2 minus negative 6 is actually the same as 2 plus 6. So we'd end up getting an 8. So one of the things you might notice real quick is the distance is always positive. And it is, right? If I talk about the distance between OBU and where I live, it's 20 miles. It doesn't matter if I say OBU to where I live or where I live to OBU, it's always positive 20. We don't talk about distance as a negative value. So when we're thinking about this on the number line, let's talk about why that works. So if we take a look at that, we'll do the, which one do you want to do? Do you have an example? Oh, I have it on the next page. On the number line for this one, the 6 and the 2, the original one right here. If I talk about 0, 1, 2, there's my 2, 3, 4, 5, 6 is here. So this is the distance. Wow, not what I meant to click on. This is the distance I'm talking about. Be real careful. Sometimes people want to count like the hash marks here in between the 2 and the 6. That's not the distance. The distance is the spaces. So if you imagine starting either direction, it doesn't really matter, and sort of making jumps like on hopscotch. This is one move. It's one distance unit, 2, 3, and 4. There are 4 spaces between them. So the distance between them is actually 4. Okay, so this is more right here, like an equation perspective, right? Larger minus smaller. This right here is a graphical perception. Are you visual? Are you algebraic? I don't know. And it doesn't matter to me which one you use. The algebraic one tends to work better if the numbers get larger that you wouldn't want to draw, right? If I said 52 minus 67, I don't think you really want to draw that out. But if the numbers were small enough to draw, it would be reasonable to do a graphical representation. So let's do an example with -6 and 2, like I just mentioned a moment ago. So a moment ago I mentioned that the larger value minus smaller would mean that we're going to do 2 minus the -6. It changed the signs and it became 2 plus 6 or 8. So that's the equation perspective that I already mentioned earlier. If you're doing this from a graphing perspective, which you could do too, the numbers are small enough, you definitely could do that. So here's my number 0, and there's 2. And then I need to go to -6. So there's -6. So what I would actually be measuring distance-wise is this span of numbers. Well, because they happen to be both on either side of the number line, you could actually talk about this being 2, right? 2 is 2 away from 0. And this being 6, because 6 is 6 away from 0, right? The -6. And so we end up with the 8. Or you could literally do the hopscotch and counting like I did before. Either way, you get the value of 8. So as you do your homework, I hope that you've already done this. I mentioned it last time, but I'll mention it again too. Please make sure to show what work you're doing. For example, if you jumped from 2 minus -6 and just wrote down the number 8 for me, that's not real helpful because I want to know that you understand the process, not that your calculator can do it. I know your calculator can do it. I'd like for you to actually show me something in between there that shows this change to a positive. A number line. You could justify it with a number line on this one. That would have been fine too. So either of those methods would be okay with me. Any questions about distance?